So here I am in my storage shed. I built this little shed just for my heating system, basically. What I have here is my 400-gallon tank that is triple insulated. I use this thermal foil bubble wrap stuff. There's 3 layers of the stuff on it. Works quite well, actually. It retains the heat into this tank for days and days. But it's still not a perfect insulation. Ultimately, I want to better insulate this system. There you can see I have the water pump that flows the water out of this tank. Basically, this nozzle here has an extension. The water is pulled from the bottom of the tank, comes up through here, through this pump. It's a 3-speed cheapy pump, $100 pump. Flows into the shop. Water's heated, comes back out of the shop into that line, which then flows into this T. Now, the interesting part about this T is this is output to the house. This is input from the heated water, and then there's this T goes into the tank, and there's a 4-inch extension off the bottom of this thing, so it pulls the water from 4 inches down and not right at the surface. I also have my expansion tank in there, which is necessary for a boiler system, because as the water expands and contracts, if you don't have that, then the water will constantly be blowing off on the thermal relief valve, or pressure relief valve as you have it. It does both. I have a pressure temperature gauge in there. As you can see, the water right now is only at 130 degrees at 15 psi, so I just lit this thing. It's warming up. The water at the bottom of the tank is at 113 degrees Fahrenheit. The way I have this system here, I have the lines going in and out of the house. I also have water coming out from my house to fill the system, so it's on an autofill valve. So anytime the system needs water, minimum 15 psi, this will introduce more water into it. And also run an outside tap off that system. There I have a second 3-speed pump. This pump here is responsible for pushing the water in and out of the house. The water goes in through the pump. 100 feet of line goes to the house, heats through the water heat exchanger in the house, and then comes back out the return line here, which then returns the remainder of the hot water back to the bottom of the storage tank. Now, the way this system works is anytime the boiler in the house calls for water, or calls for heat per se, any one of the thermostats that calls for heat in the house switches on the circulation pump in the house. At the same time, it switches on this circulation pump out here, and I did that by running the electrical line from the boiler in the house. So when that pump runs, this pump runs, flowing the water in. Anytime this pump runs, it's pulling water out of the tank. But anytime this pump runs, the hottest water in the system is coming directly off the boiler outside. So when this is calling for water, now the water, instead of going into the tank, will bypass right through this T straight into the system. So you're getting the hottest water, which right now is at 190 degrees approximately, going straight through into the pump, into the house, returns back to the tank. When that system stops in the house, the light goes off here on that plug. It stops this pump, the house pump stops, the water no longer flows through here. So then what happens is the water coming from the shop, instead of being used through this system, now goes down into the storage tank, from where the hot water goes in the top and has to push all the cooler water down to this point where the cold water is being drawn up out of this side. So there's a constant mixing happening here, and there's a constant mixing happening there. Just the way that I set the plumbing on this thing is that when you're calling for heat within the house, it's taking it from the hottest water at the top of the tank. But it just also worked out that it's also taking the hottest water directly off the boiler in the shop out there. So that way, anytime it's heating, it's using the warmest water there is. And yeah, so this is basically my setup here. It works quite well. You know, it's insulated, holds a lot of heat 400 gallons you may think is a lot of hot water, but honestly, if I get this tank up to 190 degrees and I shut the boiler down at night, this tank will only heat the house through the night, depending on even how cold it is outside. So how much heat load my house is taking determines how long this hot water will last. And it doesn't last long. Basically on 400 gallons I can get only about 12 hours of heating to keep the house warm at night. And we turn the thermostats down at night too, so it's not constantly keeping the house at 20 degrees or 22 degrees. The wife likes it warmer. I don't mind it warm. Hey, if I don't have to pay for heat, I'll heat the crap out of it. I don't give a shit. Anyways, eventually this, I think I'm going to be replacing this either with a secondary tank or maybe bigger tank. I'm not sure what we're going to do here. The shed has 2 big doors, so I can easily move tanks in and out of the shop. Anyhow, well, I'll take you into the house and we'll show you the rest of the boiler system that ties into this, which is pretty much simple within the house. But this is the heat storage system, which you have to have with any type of outside boiler system. So here we are now down in my basement, where I have the rest of my boiler system. Now this is the existing, it's a high efficiency boiler, burns natural gas. But as we're getting raped by these fucking natural gas companies and our government, their fucking stupid carbon tax, which pisses me off to no extent. I pay more in carbon tax and more in delivery fees than what I actually use for natural gas. Is absolutely sickening the way they're screwing people in this country for this crap. Anyhow, that's another story. This here is the water system coming in. It comes in from the outside, passes through the PEX lines, and the PEX is another thing that I'm not too crazy about. On the output side of my boiler, I'm going to be replacing that with straight copper because the PEX, I don't trust it. I've had a couple of failures already because it can't handle high enough heat consistently. So anyways, this is the temperature of the water now coming in from the storage tank outside. And you can see here at 150 degrees Fahrenheit. Then passes through here, which goes through a 20 plate heat exchanger, which is capable of transferring 330,000 BTUs per hour. Basically, the water on this line will be cold, and this line will be so hot in one pass that you can't barely touch it. That's how much the water can heat this system through this plate exchanger. Now, the system is running right now, so anytime this pump switch is on, it then sends power outside to my pump out in there to circulate the water in and out of the heat exchanger. So we're preheating the water before the boiler, and that way it keeps the temperature up on the boiler to the point that the boiler will not call for heat. Once this thing drops down to 130 degrees, it will then call for heat. So if there's not enough heat left in my storage tank outside, the boiler will then light up and light and heat the water. That way I'm never without heat, and keeps the system warm. The other advantage to that is I can easily switch between the two. If I go away or whatever, I just basically shut this thing off and the gas boiler takes over. Anytime I'm home, both systems are up, and now it just shut off. So that means now that there's no longer water flowing through the house system. The waters obviously don't mix because it's a plate exchanger. One water is used to heat the other, but they don't actually mix. A lot of people don't understand how a plate exchanger works, and it's basically two sides, input and output, and an input and an output, and the waters pass through plates between each other. One heats the other, but they don't actually mix. So this water doesn't mix with this water ever. The output on this side here is going to be connected. That's going to be another output, which is going to go to heat my domestic hot water, which I haven't gotten around to building this yet, but that's going to be the next on the agenda. And then that line will be the return back to the boiler system. Then this will be controlled by an electronic zone control valve, which is basically the same thing you have on your interior house. You have these zone valves which heat the 4 different zones in my house. This is going to have 2 zone valves, one to heat this zone and the other to heat that zone. I'll probably end up putting in a 3rd zone because I eventually want to use this to heat my hot tub outside as well. So yeah, there you have it. This is my take on a homemade waste oil boiler system that actually functions, and something that I can actually use to heat my home and get away from burning natural gas. Waste oil is free everywhere. It's about any shop will gladly give you their waste oil. But the thing is, you need to build something or buy something that actually functions and is safe. You don't want to have an issue with fire or something like that, or spilling oil anywhere. I'm very careful with my system, but it does function and it gives me plenty of heat. My house is 3,700 square feet, so it takes a lot of heat energy to heat this house. But this system is perfectly capable of keeping up to the heat demands. And once I connect the hot water and everything else, then I'll be able to use unlimited hot water, which just be an added bonus to it. In the summertime, this thing will be solar heated solely only for the hot water usage, because you still need hot water year round for washing clothes, showering, whatever have you. But obviously the heating system will not run in the summer, so the zone controller will be bypassing the plate exchanger, but will constantly be pumping through to heat the hot water tank. So the system will run 365 days a year. So there you go. Let me know any comments that you have. If you like this thing, it's pretty simplistic system, but it's taken me a lot of experimentation over the years, and I finally feel that I come up with something that works. But I will be improving lots of different aspects of the system. The biggest thing is boiler coil design within the stove. I'm going to be going back to a roof-mounted coil inside the stove, so that I can still burn firewood within the stoves. Because having the ability to burn wood and oil is nice. I haven't been burning any firewood this year because I'm strictly running oil. The nice thing about it is the oil makes no mess. There's no ashes, there's no smoke outside or anything like that. My stove burns clean as it is already, but just running strictly on oil has definitely been a bonus. So thanks for watching, and let me know what you think.